right, awesome. I think we can kick this off. Yeah, so I'm pretty excited to have today's tech talk. I think we're gonna talk about ZK, EVMs, and everything related. Yeah, I'm not sure what's the best way to introduce you. I don't know if you, what's your full name or official, or how you wanna, if you wanna do yourself a quick intro, and we can take it from there.
Yeah, sure. So my name's John, or if you know me from Twitter, expect chaos. I'm mainly doing blockchain research, primarily focused on the modular architecture side of things. I've spent quite a bit of time looking into different roll-up systems and the kind of zero-knowledge proof systems that they use, but also more broadly in terms of the modular design space, what it offers, what the I guess main challenges are that rollups are facing: data availability, decentralizing sequencers, decentralizing the prover in the CK case. And I guess what is maybe worth mentioning here is that originally I do not really have a tech or IT background. So when I came across, or when my interest in blockchain technology was sparked, that was actually during my business administration bachelor's at a business school in Switzerland, where I was able to take a course on the basics of cybersecurity, where I got introduced to some cryptographic primitives that basically are the core building blocks of blockchain technology in the first place. And after that, I tried to basically, spend a lot of time in my free time on diving deeper and teaching myself the whole technology stack, so to speak. I'm currently still enrolled in university. I'm doing a master's on banking and finance at the same business school in Switzerland where I did my bachelor's. I did have the opportunity to, gear it a bit more towards technology or fintech in general, as I was able to take some slightly more advanced cryptography courses and some very basic programming courses as well. But generally, most of the stuff that I write about on Twitter, or when I produce long-form articles like the one on Polygon's ZK-EVM, which I think was what got me on your radar in the first place, I mainly write about stuff that I've either taught myself, so to speak, or that I have picked up along my research journey, which I actually started with a Swiss crypto bank, for which I worked for 2 years in various departments, but especially towards the end, mainly in the research department. And after quitting at the crypto bank, I kind of continued doing the research primarily on the modular design space to kind of create content for my Twitter, and just more generally to kind of raise awareness of all the amazing innovation that is happening in that regard.
Amazing, awesome. Yeah, and kind of came across your blog, kind of, I think probably shortly after you wrote it. So it was really one of the most comprehensive summaries that kind of came across. So yeah, I mean, do you want to walk us through it, or I think would be, just great if you can open up the discussion and we can take it from there.
Yeah, sure. I mean, is there any specific parts you want me to kind of elaborate on, or should I just...
I think if you give like an overview of, how different projects approach, using ZK, right? There's different like trade-offs, of course, depending on what you do. I think just, talking about that, what advantages, disadvantages, I think would be, super good start.
Yeah, so I guess primarily focused on the ZK rollup side of things, less on generally the history of scaling and optimistic rollups and stuff, right?
Yeah.
All right. Yeah, then I think it might make sense to have a look at the different kind of types of CK EVMs to start with that we see out there, and kind of the different levels of EVM compatibility or EVM equivalence that they have, because I think that is kind of an important differentiation that exists between those different CK EVMs that we already see live or that will go live in the near future. And I mean, in the report, we have actually taken two approaches. One is the kind of framework that was put out, I think, by Vitalik Buterin himself originally, where we have the different types of EVM, as a CK EVM implementations, ranging from type 1 over type 2, 3 to type 4. And the type 4 is basically the least EVM equivalent implementation of a CK EVM. And when I say the least EVM equivalent, what I'm referring to here is kind of the difficulty or the friction that there is to the code base on the EVM, and how difficult it is for developers to actually deploy Solidity or Viper smart contracts on top of that specific CK EVM. And the type 4 CK
Sorry, just kind of take a quick pause. I know you have like a bunch of the stuff in the blog. Do you want to kind of maybe just share it, and like, you know, we can walk through some of its stuff? I think it would be good if like people at least can have a reference
share
of
my
where they can.
screen?
Yeah, I think that would be awesome.
Sure, can do that. Can you see my screen?
Yep.
Good. Yep. So exactly. So that's basically the type 1 to type 4 breakdown that I was talking about before. We also have the slightly less granular breakdown of language level, bytecode level, and consensus, and that should be a U there, not a Y, level compatibility. And maybe to just, you know, give you a quick overview, I think that the type 4 kind of CK EVMs are the least compatible ones. So Starknet, for example, which is also kind of a CK VM, but not necessarily a CK EVM, would fall into that high-level language equivalence bucket, in the sense that it is a VM built in Cairo. So you also need to deploy Cairo smart contracts on top of that in general. But there is a wrapper that they are working on to basically transpile the Solidity code that developers write into the Cairo language that is actually supported by the VM they are running. And CK Sync, for example, I hope I have more, yeah, exactly, this is probably a better one. So CK Sync is slightly more EVM equivalent. It is still considered a language level degree of compatibility, as there is a transpiler step that kind of translates the code into a more CK friendly kind of language that is then executed within their VM. Here, I'm honestly not entirely sure if the graph here that we're seeing on the screen right now is the most recent one, because I think what the kind of CK friendly intermediary language they transpile the code to is called is U, if I'm not mistaken, and not Sync. And if we kind of move down towards type 2 or potentially type 1, the CK EVMs that would fit into those buckets are Polygon Hermes and Scroll. There is a slight difference, as we can also see on this graph here, where in the case of Polygon CK VM, it's not Hermes anymore, right? But in the case of Polygon CK EVM, there are certain micro opcodes that basically add a little bit of potentially different behavior, the risk of you know, at least theoretically possible different behavior from what we would see in the general EVM. but the like equivalence level is considered bytecode. And I'm not a developer myself, but I have been able to talk to people who've been developing on CK-Sync and on Polygon CKVM, and I've heard that it is actually quite a difference in terms of development overhead that comes with deploying Solidity smart contracts on CK-Sync as compared to what a Polygon is offering. And in terms of Scroll, there are no proprietary micro opcodes that express stuff that can, not be represented within the CKVM implementation that they have. So Scroll is, at least for now, and based on the understanding that I have, the most EVM equivalent execution environment in terms of zero knowledge rollups that we have, or that we will soon have, I hope. And just in general, I mean, so do you have any questions at this point, or?
Yeah, I mean, I had a question, but I guess so as you look at across the changes, could you give specific maybe example of some things that maybe may work right on Scroll, but may not work, let's say on StarkNet, right? And is that a question of, for instance, what could break around the stack? Is it some of the tooling could break, some of the debuggers could break? Is it, nothing? I think if you have any sense of what are the examples of things that work across, or some of the things that break for developers or need to be rewritten, I think that would be super helpful.
To be honest, I cannot tell you in detail, but generally, I mean, for StarkNet, for example, which is actually a virtual machine based on Cairo, I think the kind of tooling that you have is in general different from what you would have on a fully EVM equivalent environment like Scroll. I guess with Scroll, at least that's from what I've heard from kind of conversations that I've been listening to that the team has had on Twitter Spaces or in podcasts, you should be able to literally kind of use all the Ethereum development tools or that you have, and it should not break. And the same holds true to my understanding for Polygon CK EVM. I can follow up with the team that I'm in touch with that is building on CK-Sync to give you a clearer picture on kind of where exactly they came across, issues or frictions with the tooling that they were used to, if that is of any interest, and I can get back to you on that. But personally, I cannot give you any detail on that, I'm afraid.
Sounds good.
Yeah, I mean, in general, I mean, feel free to kind of, push me towards the kind of things that you want to talk about, or the kind of maybe architecture related topics that you're interested in. But generally, I guess from a trade-off point of view, it's also kind of important to mention that for example, CK-Sync has kind of deliberately gone with this less EVM equivalent approach, just like StarkNet has not had the vision of building a fully EVM equivalent environment from day one. So it's not necessarily a way of kind of assessing these different rollup execution layers, but it depends on what they are optimizing for. And I guess, for example, CK-Sync and StarkNet argue that by not aiming for the highest possible degree of EVM equivalence, they can achieve certain benefits on the performance side with regards to throughput that their execution layers enable. And in the case of CK-Sync, at least, I think that's a bit different with StarkNet, because Starks are generally rather computationally intensive. But with CK-Sync, I guess the argumentation was also around, being a kind of a more cost-efficient execution layer then it is possible if you go for full EVM equivalence. Interestingly, that is something that I would say to my, at least in my understanding, has not really materialized in the form that they were expecting, because Polygon, which I'm very much a fan of in terms of their cryptography work that they have done, have developed Plonky 2, which I think, at least on the data that I have seen, really is the most performant and I guess cheapest zero knowledge proof system to verify proofs on Ethereum. And even though Polygon has a higher degree of EVM equivalence, they are not lagging behind ZK Sync in terms of time until the proofs are generated and verified, and the cost is also very much comparable.
Good. I guess a good question. So, and the type of ZK that's used by the system, is it like different? Is everybody using like, kind of a Plunks of the world, or everybody relies on like different technology? And Stark's probably doing their Stark stuff, right? But
Yeah.
the other ones.
Exactly. So Starknet is using Starks, as you said, and ZK Sync is using Plonk. I think it's like the plain original Plonk in that, as if I'm not mistaken. And as mentioned before, what Polygon is using is Plonky 2, where they kind of combine certain elements from the Starknet or Starkware technology stack with Plonk proofs. I think I have to quickly to make sure that I'm not telling you anything wrong here. Check that here. Yeah, exactly. So exactly, they kind of use they use Stark proofs basically at the core, but because their size is much larger than Snarks, they kind of leverage this asynchronous property of Snarks to wrap these Stark proofs for final verification on the in the corresponding like rollup verifier contract that resides on the layer 1, and by kind of leveraging the benefits that the Plonky, the Stark side of things has in terms of providing more scalability, while still being able to kind of verify these proofs efficiently. I would say they have developed something that is superior to the like plain Plonk proof system that ZK Sync is using. I'm honestly not entirely sure what kind of proof system Scroll is using, for example, but I would say that most projects out there that I'm familiar with or that I have looked into actually use Plonk or some variant of it. That also holds true for like a number of projects outside of the kind of Ethereum ecosystem, such as Mina, Dusk, Manta, which I would all consider to be kind of pioneers in the CK layer 1 space, so to speak. I can
remind me.
Sorry.
Sure, and yeah, remind me the Plunky or Plunky 2. I actually don't know. It all has like trusted setup, so you have to run like the verifiable circuits, or
for example, Plonk has a universal trusted setup. So ZK Sync, if if I remember correctly, actually uses the trusted setup that was generated in Aztec Network's original trusted setup ceremony, as it can basically be recycled. And with Plonky 2, I think we kind of have the same case. Let me quickly verify that, but I would say it's also a universal trusted setup. Yeah,
also
exactly.
like a single one.
Exactly. Sorry?
Yeah, you only need to run it one time essentially, and then you can
exactly. You need to run it one time, and then you can kind of recycle these parameters for other applications. And I think the ad stack ceremony. Wait, maybe I actually have that link open here somewhere. Yeah, exactly. They're using the common reference string from the ignition ceremony organized by AdStack, which happened a while back, yeah, in 2019, exactly. And with Polygon CKVM or Plonky 2, they have actually managed to remove the need for a trusted setup entirely. So Plonky 2 doesn't rely on a trusted setup anymore. And I guess this is what I was referring to before. So they kind of combine Plonk and FRI, the commitment scheme used in Starks, which enables the quick proof generation that we know from Starks in the absence of a trusted setup, which is kind of a benefit that comes with Plonky 2, and still, you know, maintaining the recursion support for potential layer 3s or whatever use cases are enabled by that, and the low verification cost, which is actually evidenced by production data as well as their proof system, regardless of the high degree of EVM equivalence their VM implementation provides, is basically on par with what zk-Sync has, with a, I would say, at least in that regard, a bit less advanced proof system.
So what's the approximate cost, like gas cost of verifying any of these proofs?
Wait, let me quickly check on that, because I know that there was a post on that not too long ago. Because I don't know it by heart, because we abstracted some complexity from our report. So unfortunately, I do not have it here in terms of numbers, but yeah, like that, it's probably difficult to find. I should have prepared that beforehand, because I was actually thinking that these kinds of metrics would be interesting, but then I ran out of time. I'm gonna follow up on that, because I'm sure I can you know, provide you some numbers on that, but off the top of my head, I'm afraid I don't want to make any assumptions.
Okay, yeah, no worries. And I guess, sorry, then just another question. So, you know, all of these L2s, right, will produce proofs. The proofs are, you know, L1, they're sort of verified. But suppose like an L2 kind of a forks, right? Or there's like a, you know, mistake, and then there's another proof that's sort of generated for the same block. Then, you know, you post it on L1, it should reject it, right? But this is just like one of the attacks, but, you know, I have to think a little bit more, but like I could imagine there's a, you know, pretty large spectrum of attacks you can pull off to generate like proofs for, you know, maybe like different blocks, right? Or some conflicts. And so your layer 1 kind of the verifier will have to, you know, protect against all those, right?
Yes, I would say that is true. I mean, I would have to kind of think about it a bit more as well to, you know, get a clearer picture of what the exact attack vectors here also are here, because yeah, Yeah, but
So-
generally, I mean, I guess it is kind of hard to you know try to trick the verifier contract into accepting a proof that is not based on valid transaction information. I'm sure there are ways to kind of find an attack vector to make that happen and kind of provoke a fork, as you've indicated before. But I would say it's rather complex.
But so who can post the proofs? Is it usually like a centralized sequencer that's sort of whitelisted, or because so I guess, you know, concrete attack, if anybody, so technically, let's suppose like anybody could post the proof, right? If to make it like as decentralized as possible. If anybody could post the proof, then I could go produce blocks, right, for the future, you know, like 1,000, you know, minutes, right, for 1,000 blocks that only includes like my transaction, submit it to like layer 1 verifier, claim all those spots for all those blocks, and then the actual like prover that does like a better job, you know, would not be able to do it because like, you know, those blocks are taken. So do they whitelist kind of the provers in this case?
Yes, so currently all CK rollups that we see live in production have a centralized prover system that is basically as an infrastructure which is normally provided by the team. So at this point, I don't even think that, or at least I'm not aware of a team that actually runs a whitelist in that sense. I think the setup is even more centralized. There is both for the sequencer that kind of batches the transactions and sends them to the prover for proof generation before then kind of relaying that information to the base layer. Both for the sequencer and the prover, we currently have only centralized kind of setups in the CK rollup world. This is something that will definitely change over time. Scroll, for example, has actually proposed a mechanism for kind of a prover decentralization that I've also outlined in brief within this article here. Exactly, where I mean on a high level, it's basically you have this how do they call it, rollers, which are basically the entities that can you know, generate the proofs, and that kind of works in, at least it's not the same obviously, but in kind of a, you know, proof of work style setup where these rollers compete with each other to generate the proofs that will then be used to to verify the transaction batches accordingly, which would, I guess, be kind of a permissionless system that you were referring to before. But I remember that it has some, you know, security layers in terms of a kind of a reputation system and also kind of stake that the rollers have to put up to, you know, disincentivize dishonest behavior, or get the way around, incentivize honesty. And with the sequencer, who also has a lot of, you know, power within that system, and is also something that should not be kept in this kind of centralized setup for, in the long term. We also see the concept of shared sequencer networks emerging. So like Austria is a project building something in that regard. We also have Espresso that is working, as Espresso network that is working on a shared sequencer. Flashbot's Suave network is aiming to achieve something similar, where you have a decentralized set of nodes that basically take over the sequencing for roll-up networks, and more importantly, I guess also from an interoperability point of view, for multiple networks at a time, where they can kind of aggregate the transactions into one block that is then, you know, including data from multiple rollups, which kind of makes it easier for them to access each other's state information.
And all of the L2s posting their kind of transaction, on chain subsequently once the proof is generated, or like on the layer ones itself, or some of them kind of just post the commitments and like relevant transactions.
I mean, if we talk about the CK EVMs that are currently live, Polygon CK EVM and CK Sync, what they post onto the Ethereum layer 1 are the state differences, if I'm not mistaken, in the kind of broader zero knowledge rollup space or CK scaling space. We also have other implementation forms that kind of differ from the true rollup architecture, in the sense that they do not rely on the Ethereum base layer for data availability, as data availability is basically the main bottleneck for rollup based scaling solutions, as the capacity of the Ethereum layer 1 to kind of process data that rollups or the rollups sequencers dump on it is rather limited. And before, also in the current state of the world, so before EIP 4844, rollups are forced to pay for call data to have their state differences posted on, and in that case even permanently stored on the Ethereum base layer, which means that they are competing with general execution on Ethereum's smart contract environment, which is not ideal, as they are very adversely affected by spikes of general activity on the layer 1, which can also negatively impact the cost that is incurred on these layer 2s. And hence we have already in the past seen certain projects opting for off-chain data availability solutions. So I'm not sure how familiar you are with that kind of terminology, but there is what's referred to as validiums or pure validiums that use basically a single off-chain data source or some sort of an off-chain entity where they store the transaction data and then only posting the corresponding proofs and maybe some sort of an attestation for the data being available onto the Ethereum chain. Same is with more, I would say, contemporary validiums that normally use what is referred to as a data availability committee, which improves on the pure validium case, as there is a set or a small number of trusted institutions that kind of guarantee for the off-chain data to be available. And similarly, normally there is sort of an attestation that these committees sign and then post onto the Ethereum base layer. Immutable X, for example, is a CK, like as an example of a validium in the CK case. We also have a similar thing on the optimistic side of things. There you would not necessarily call it a validium, but Metis DAO is often referred to as an optimistic chain rather than an optimistic rollup, because it actually does the same. It has a sort of data availability committee that guarantees the data being available while transaction data is being posted to Memo Labs, which I think finally posts the data onto Arweave as a storage layer, and hence the amount of data that, for example, Metis or in the CK case, Immutable have to post onto the Ethereum base layer is much smaller than the amount of data that a true rollup that uses Ethereum for both settlement and data availability has to post, and hence the cost that users incur when interacting with these systems is considerably lower than with true rollups, because with the current rate of 16 gas per byte of call data, this is really the main like cost components that make up the fees that you have on rollups. So I would estimate that between like 80 and 90 or even 95% of cost that rollups incur is actually the data availability cost on the base layer. And so far, I would say, you know, most rollups are still opting for having data availability on Ethereum layer 1, mainly because of the rather obvious security trade-off that come with the data availability committees that I've mentioned before. But with the whole modular thesis and the, I would say, like broader modular design space gaining more traction and also kind of maturing in terms of the tooling and solutions that are available there, I would expect that to change as, for example, Celestia or Avail will provide scalable layer 1 infrastructure that is specialized on, you know, enabling these kinds of rollups to rollup-based scaling structures to verify that data is available in a much cheaper and much more efficient way. And within the Ethereum ecosystem, I'm sure you're familiar with EigenLayer, which will also have its own middleware service called EigenDA, which is similar to kind of Celestia or Avail, a general purpose data availability layer that allows rollups to post data onto that kind of, you know, middleware layer that is being maintained by nodes that restake their Ethereum to secure that specific part of the middleware that EigenLayer is offering. And with these kinds of solutions emerging, I would say we will in the future, you know, have more diversity in terms of where data is actually being posted to, if that makes any sense.
Makes sense. And what's the provers time in, you know, some of these cases? Are we talking about like minutes, hours? Like, yeah, could you give us a bit of a sense?
Generally, it's, I don't have the numbers by heart for all of them, to be honest. I can I can show you this maybe. I mean, the Plonky 2 system that I've mentioned before in the context of Polygon's zkEVM is, I would say, the fastest one based on the numbers that I have come across so far. And based on the information, I think this was information that the team supplied me. It literally just takes milliseconds to generate a proof on even very limited hardware infrastructure. And generally, I would say, you know, we're talking about as a maximum minutes here. I would not say that we're still in the ballpark of hours, but at the end of the day, it does depend on the proof system, because, you know, like the Stark proofs, for example, because of their larger size, I think take more time to verify, even though they're, you know, generated rather quickly.
I think for the Polygon zkEVM, it seems like the proofs are posted once every hour. I guess like the sequencer seems to submit batches like, you know, every like 5 minutes or something, but I believe they aggregate all the multiple batches into like one proof. So the verification is still like 1 hour. I mean,
Yeah,
it's relevant for us because like we have to wait for finality, so like that adds more finality time for bridging purposes. But it seems to be still quite a bit.
Sure.
I guess more than even like optimistic rollups, right? Because for Arbitrum and whatnot, like they submit batches more frequently, I believe.
Yep. And actually, that's a good point you're mentioning here. I mean, that is something that I would expect to, you know, be optimized in the future. If we look at Starknet, for example, at this point, I think they actually only post the proofs, as you say, you know, in an aggregate form every 5 to 8 hours or something. So that is currently very at a very low frequency, but they are working on optimizing that, and I think that will, you know, reduce in the future for all the kind of proofing systems. That's one that I'm very much aware that they are working on improving that.
Did you do any research on Aztec compared to these other L2s?
To be honest, I mean, I looked into Aztec a while back, but that must have been like a year ago or something, and since then I have not spent much time on Aztec, to be honest. Anything in specific that you're wondering about in that context, or?
More interested, like from a commercial perspective, like are they in the conversation with the same, you know, developers that may be analyzing the differences between launching on Polygon ZK EVM or Scroll? Like, is Aztec, you know, competitively in this market right now, or are they considered a secondary or tertiary option?
Yeah, I mean, I think they kind of differ a bit from the before, so from the generalized CK EVMs that we've been talking so far about so far, in the sense that they optimize much more for privacy, right? I mean, just having a CK rollup doesn't guarantee privacy to the users, because how the zero knowledge proofs are kind of used and implemented within a system heavily influences the degree of privacy that comes with it. And as far as I'm aware, actually, most of the zero knowledge rollups or the CK EVMs that we've talking about so far only kind of provide a limited degree of privacy, because while they do leverage the succinctness property of zero knowledge proofs to scale kind of the computational throughput of their networks, they do not leverage the zero knowledge property to the fullest extent, as far as I've come to learn while I was researching that stuff. There is some sort of way in most cases to kind of decode the proofs and reconstruct the rollup state in case that something goes wrong on the rollup, which is not the case with Aztec, but Aztec for you know, at least some time, as I'm aware, was more of an application specific kind of use case that was literally solely geared towards privacy. I know that they're coming up with a more generalized approach now as well, which should kind of enable both private and non-private smart contracts to be deployed and interact with each other. But to kind of answer your question, at least in, let's call it my information bubble, I would say the you know, amount of mentions or the is considerably lower than the CK EVMs that we have been talking about so far, which I would say are more prominent in the space overall.
Thanks. That was very helpful.
Yeah, basically Aztec isn't building in a ZK EVM as far as I understand.
Yep. I think at this point they are. Initially their solution was kind of different, but yeah, at this point that's my understanding as well. But again, I think it has considerably less interest or traction at this point in time, at least, so it hasn't surfaced too much in the conversations that I was engaged in, and is often missing when people kind of compare general purpose smart contract execution layers that are powered by zero knowledge proof systems within kind of the Ethereum ecosystem. I think it's a bit overlooked at this point.
Thanks.
Yeah, is there anything else in specific that you're wondering about, thinking about what could make sense to, you know, get?
I have a question maybe. What do you see, like, do you see these different ZK VMs as competitors? Do you see some of them dying out? Like, why is the market, does the market need like 6 different ZK VMs?
Yeah, that's actually a good question. To be honest, I think it will be hard for you know, all the ZK EVMs, as they kind of provide very similar services at the end of the day, or a very similar value proposition. I think it will be hard for them to all, you know, coexist with each other without having at least 1 or 2 clear winners that will benefit from the network effects that come with you know, a maturing ecosystem in general. But I would not even say that the main problem is that we have too many ZK EVMs at this point. I just think that with the advances that we see in the whole roll-up space, or maybe more broadly, like the modular design space, we will see literally an explosion of different kinds of roll-ups. And, you know, most of the discussion, I guess, currently around roll-ups focuses on EVM compatible roll-ups, on EVM equivalent roll-ups, whether that's in the ZK case or in the optimistic case. And I mean, that is just kind of the start. It makes sense to have an EVM compatible or equivalent VM, because you can easily, you know, bootstrap developers and users from the largest pool of developers and users there is, which at the end of the day is the Ethereum, or more broadly speaking, EVM universe. But there are many, for example, that's something that I've been looking into lately as well, many different kind of roll-up as service providers that come up with SDKs and frameworks to, you know, lower the barriers of entry to deploy roll-ups, modular roll-ups that potentially use any kind of settlement layer and any kind of data availability layer. So the, like, I would say, level of customization that these different rollups can have in the future will massively increase. And while I still, you know, expect many rollups to use Ethereum at least as some sort of a final settlement layer, even if they, you know, kind of settle on a layer 2 first as a kind of layer 3 structure before then finally settling on Ethereum layer 1, I think there will be like a massively increasing number of these rollups. And as I've mentioned before, the kind of design space will also become much broader, and we will not only see EVM rollups, but we will also see rollups that run the C-level VM, so a kind of Solana virtual machine. We will see rollups that run the Move VM, like Aptos and Sui style. We will see rollups running the Fuel VM. I mean, Fuel version 2 is going to be the kind of first example of that, which I would assume is going to be live within the next few months as well. And then I think, you know, it gets really, really interesting. And then we can also kind of ask the question whether the EVM, which certainly has some limitations to, for example, the lack of parallel transaction execution, just to mention one here, whether the EVM will actually be or remain the kind of, you know, dominant execution environment, and why maybe, you know, should a developer in the future, if he has all these, I guess, at least from some perspectives, if we talk about throughput, superior VM implementations available that also kind of share the security with the Ethereum base layer, if you have a mature roll-up architecture, why should the developer then still go with the EVM or an EVM roll-up, so to speak, right? I think we will see a lot of competition from that angle as well. And at the end of the day, I think what it all boils down to is that we will have, it's hard to, you know, put numbers on that, but I guess with a growing ecosystem, the number of these layers can also increase. We will have one main security layer, which is Ethereum. Then on top of that, we will have a certain number of general purpose execution environments that some of which might be EVM environments, some of which will be Solana VM environments, some will be Move VM environments, some might be Fuel, whatever. And then on top of these, I would expect, you know, the main kind of application layer architecture that will be emerging is then application specific layer 3 structures. That's also something that I have noticed in especially conversations with these SDK teams, is, you know, something that is kind of gaining traction, at least among the people that kind of look into that modular space, because it will, and I've actually seen some live demos of products like that, become super easy to deploy application specific rollups. So while today, when you have a smart contract, you would maybe go to Ethereum layer 1, maybe Polygon proof of stake or Binance Smart Chain, and deploy your Solidity contract there. You can, you know, using these frameworks like Caldera, Vistara are 2 examples, but also Sovereign, which I guess will take a bit more time to actually mature. But for example, with the first 2, you will actually have sorts of a dashboard with drop-down menus, and all you need to do is literally connect the GitHub repository with your smart contract. You choose the execution environment based on what language your smart contract is written in. So let's say Solidity, you choose some sort of a CK EVM as your execution environment. You choose Celestia as a data availability layer, you settle on Ethereum or some sort of a layer 2, and then you choose a decentralized sequencing service to kind of take over sequencing for your rollup, and you press deploy, and literally within seconds or, you know, minutes, your chain is live, and your smart contract that would have otherwise been deployed on a layer 1 competing for block space with all kinds of different applications is then live in its own little kind of state machine as an application specific roll-up on top of whatever infrastructure you have defined. And with that, I think, you know, we have a kind of a true chance of reaching the levels of scalability that are necessary to support applications that, whether it's a game or financial applications, that can actually support millions of users, or what is often referred to as kind of mass adoption. But sorry for probably not exactly answering your question here, because I think your question was how many CK EVMs will there be? And I think that's a hard question to answer, especially with the competition from other VMs. But I think there will be a few as the ecosystem matures. But we can currently see already, I think, that it's kind of hard for all of them to gain traction at the same time. And if you are missing airdrop incentives, like is the case with a Polygon CK EVM, you can have the superior tech, but you're still not going to get any liquidity and users on board. So yeah. I think kind of a lot of factors that play into that.
Yeah. Some of them are only VM implementations though, like Scroll, for example, they aren't releasing their own rollup, right? They're just a VM implementation.
I mean, I would maybe I'm wrong on that, to be honest, because I have not done detailed research on Scroll. But to be honest, I would have expected Scroll to actually launch its own rollup as well. However, I could be wrong on that.
You mentioned that there are multiple projects already working on L3 implementations. Are these like, you know, could you segment, or do you have any insight into who these are? These generally Web3 native projects, or are these the type of enterprises that were previously looking at launching like subnets?
As from from like the experience that I have or the conversations that I've had, I would say that's mostly like kind of Web3 native projects. So, for example, I'm currently working with a team that is building a modular kind of layer 3 role app, I think is the most correct term to refer to that, which will basically be a derivatives trading platform that is you know, implemented as a layer 3 on top of some sort of a layer 2 that's that we settle on, that finally settles on Ethereum, which will kind of provide consensus and security guarantees, while also plugging into some sort of a scalable data availability solution, preferably eigenlayers, EigenDA, to you know, enable maximize the throughput and low costs. And I think it's actually an interesting point that you were mentioning here, because personally, like just from my point of view, I would expect this kind of, you know, application specific layer 3 implementation of whatever kind of app. I would expect that to be something that institutions would, you know, also kind of like to adopt in the future. But at this point in time, the interest that I'm aware of is mainly Web3 native. So games that want to kind of, you know, run their own or deploy their own rollups, their own chains, but also DeFi applications. I think we were, and you guys coming from the Cosmos ecosystem will probably second that. I think we're moving towards an application-specific world, a world where we see less, you know, smart contract-based applications, but rather app-specific chains. And maybe one example that is actually interesting to mention here is Immutable X, which a few weeks ago, or maybe a few months ago already, I'm not so too sure on the time horizon, has partnered up with Polygon to basically create its own version of the Polygon CK EVM. They will use the same technology stack to build that. And this kind of Immutable X CK EVM will provide, or is actually envisioned by the team to provide the base layer infrastructure for application-specific layer 3s that the games that they are working with will deploy on top of that environment. So I think that is a big one.
Thanks. Interesting.
Any thoughts on like consensus ZKVM and their stack? Like,
I mean, generally the DCK rollups don't have a consensus mechanism of their own, right?
oh, sorry, I meant the consensus.
Oh, consensus.
Yeah, like linear.
Yeah. I mean, to be honest, I think Linea is built on the OP stack, if I'm not mistaken, right? So it's basically very similar to Optimism in terms of technology, but I have not done in-depth research on Linea. I've just played around with the testnet a bit so far.
Mm-hmm. Yeah, they seem to be doing like a rollout of ZK tech rather than having a full ZK EVM right up front, from what I understand.
Yeah, but do you know if it's actually based on the OP stack? Because I might be confusing it with Base, who is definitely built on the OP.
I think you are.
Yeah, Bases. I don't know what the stack Linea uses, whether it's an in-house thing or not.
Yeah.
I mean, I guess like the new OP Bedrock stack can allow for ZK VMs too, because I think that was a big point of the new stack they're pushing. But yeah, I'm not sure what they're using.
Yeah, but yeah, I think I just confused it with Base, to be honest, because as you say correctly, I think Linea is, you know, taking the CK approach, whereas Base is actually an OP stack based optimistic rollup. Yeah, sorry for the confusion. Yeah, anything
Awesome.
else? Anything specific that I have not touched upon or that you want to ask?
I think this has been great, and I think, yeah, we're kind of at time a little bit, but yeah, I mean, would love to just kind of stay in touch. I think if we have any questions or in the team, like we could potentially, I guess, yeah, pin you or take it
Yeah,
from there.
sure. And I mean, as I've mentioned before, like with the team that I'm working with on, also with regards to the application specific layer 3 rollup thingy, we are also you know, in the process of exploring the broader modular space for all the different kinds of building blocks that will enable us to kind of build out this use case in the best possible way. And one very important consideration that we have to make, and one important topic that we're currently looking into as well, is the kind of, you know, bridging solutions, interoperability solutions that could enable seamless liquidity flows onto our layer 3 app chain. And within that kind of conversation, I've just started looking into the different kind of, you know, novel upcoming bridging technologies. And I know that you guys don't like to be referred to as a bridging technology, but like, I guess the general message passing protocol that your building can enable more secure bridging protocols as compared to the multi-sig MPC based bridges we see today, and could potentially, you know, be something that would be very interesting for us from an application perspective to integrate with, to enable secure interoperability with other layer 1s, layer 2s, or layer 3s. And hence, if there is a possibility, I would, you know, maybe also like to have a separate discussion where we can explore the potential of Axelar in that context a bit more detailed.
Yeah, no, I think for sure we should chat. I think one of the things that, you know, we're doing is trying to kind of abstract our kind of protocol away, so you can plug in like different validation methods, right? So if you have a ZK proof, you'll be able to kind of plug in, right, and still rely like on common semantics to kind of communicate, you know, with Axel and like other ecosystems if it's available, right? And yeah, maybe let's like follow up and like let's maybe schedule some time to chat about that.
Yeah, sure. Sounds good. We can stay in touch on Twitter, or I can give you my Telegram or whatever is convenient for you guys, and then we can maybe see if we find a time slot next week to discuss something like that in more detail. And if you have any questions, feel free to ping me. Happy to provide whatever input I can provide.
Awesome, sounds good. Yeah, I'll pin you on Twitter and we can coordinate the time for next week.
Sure.
Awesome. Well, thanks so much for walking us through this.
Yeah, sure. It was a pleasure. Really, like I mean, I'm on a high level only, I have to say, familiar with what you guys are doing, but from what I was able to understand, I think you're really building a, you know, core building block for the interoperable multi-chain future that we're heading towards to. And when you, Sergey, reached out to me, I was really kind of honored that you would want to talk to me about that. And I do hope that I could at least provide a little bit of helpful information. And as I've said, you know, always happy to follow up on any more specific questions that you have.
Perfect. Well, yeah, sounds great. We'll be in touch and we'll talk soon.
All right.
Thanks again for doing this.
Later.
Thank you.
Thank you.